Hey friends, today we are going to discuss another design pattern called request pipeline pattern. Now in request pipeline pattern, what we do is if two servers wants to communicate with one another, they can send multiple requests to the other server rather than sending a single request, because a single request would not be able to utilize this server completely. So the requesting server is going to send multiple requests. Let's say it is sending M1, M2, M3 messages. Now the server which is doing the processing implements singular update queue at its end. It is going to have a single doer which is processing these requests, and as and when its work is getting done, it is going to send the responses back to the consumer or to the requester. Now it is up to the requester how it wants to consume the responses which it is getting. For example, it is getting R1, R2, R3. If it directly wants to consume those messages, it can do that. And if it wants to ensure the ordering of the messages that are coming from the doer, it can also ensure a singular update queue where all the messages are queued here. Now sending multiple messages is okay, but there's always going to be a limit of how many messages you can send before the doer gets overwhelmed. So you have to ensure that there is a certain limit on the queue size at the doer's end, and this limit has to be honored by the requester. And when the limit is breached, either the doer can send back pressure to the caller, or uh, doer or requester can basically wait till the time queue space becomes unavailable available sorry. Similar pattern is observed in Kafka, where we have max in-flight requests on a connection. So at any connection, when a producer is sending the data to Kafka, Kafka allows getting multiple messages in a single on a single channel. The channel between producer and Kafka is a single socket channel, or is a request pipeline pattern where multiple messages can be sent, and these messages, before being written to the log file, are stored in a singular update queue, and one by one Kafka's process picks up the messages that have been received from the producer and it applies them to the log file. So this is max in-flight messaging implementation of request pipeline in Kafka. Also, another way where requester can ensure that it is not reaching the limit of in-flight requests or the queue size at the processor's end is by having its own request queue size. This is the request queue size. So it is going to have messages like M1, M2, M3 and M4, and since the request queue size is the queue size at the doer's end is 3, so M1, M2 and M1, M2 and M3 are going to be in flight, and as and when these responses are received from the doer, these messages are going to be removed, and M1, M2, M3 is going to be removed from here and here from the request pipeline, and M4 is going to be sent, and when M4's response is received, M4 is also going to be removed from the request pipeline. This way, requester is able to ensure and honor the queue limits at the doer's end. So it is not overwhelming the doer. Also, there is a problem here that you can face. For example, you are sending M1, M2 and M3, but when you are sending M1, somehow it got failed and you sent M2, and after that you retried and you sent M1 again. So what is going to happen is it is going to receive M2 first and then M1. Now if you want to have a better system, what you can do is you can ensure sequencing at the doer's end or at the processor's end, so that when it receives M2 and then it receives M1, Since M1 is a predecessor of M2, but it is receiving late, it is being received late, so doer can reject this message. That way you are ensuring that you are not receiving out of order messages. You are not receiving M2 then M1. M1 is rejected, so after M2 you are only going to be receiving sequence number higher than M2. Here we are considering 1, 2, 3 as the proxy for sequence numbers. So this is request pipeline pattern, which is extensively used in distributed systems, especially the ones that we use especially the ones like Kafka. I hope you enjoyed this video. Thank you and have a nice day.